Hello everybody. I can see people joining. Good afternoon, good morning. As usual, we'll give it a few minutes for everyone to join because it always takes a couple of minutes. Yeah, I can see some familiar names, so it's really nice to see people returning to our events to learn more. So yeah, it's a good afternoon from me, from Worcestershire, UK. Hi Kai, nice to see you, sort of. Yeah, you can, if you want, you can put in the chat where you're watching us from. We've got, as usual, we've got quite a global audience, people joining from all over the world, all different time zones, times of the day. Oh, we've got some from Mozambique, that's great. Yeah, so we've got some more people joining. Let's give it another minute and we'll start. So for those of you who are who haven't really attended any of our webinars in the past, we always encourage you to take part in the conversation using the chat option. It should be open, available to everyone. You can ask your questions there during the webinar. You can also just chat with other attendees. Everyone is able to see the chat messages there. We also have a Q&A option. If you prefer to post your question there, it will just wait there until we answer it. So it's a little bit easier in that sense to manage and to see it, to preview it, because if you put questions in the chat, they may disappear, but that's fine. I'll keep an eye on those anyway, so you don't have to worry. So whichever you prefer. So yeah, a bit of housekeeping. Yeah, if you have any questions during the event, just pop them in the chat or in the Q&A at any time, and we'll get to them when ready. So you don't have to wait until the end. If you have something that just pops in your head while the presentation is on, just please, yeah, ask your questions there and then. Okay, I think we are ready to start. So welcome again. Welcome to this webinar. My name is Dominika Tasasz and I am a marketing specialist at Payara. I'm also responsible for Payara community building and organizing events like this one to educate, to enable all of the Payara community members to learn more about not only Payara, but also the technologies that we use with Payara. So today, it's another one of our webinars. Today we'll be focusing on MongoDB with Morphia and Jakarta EE. And our speaker for today is Lukman Saeed, who hopefully a lot of you know already. Lukman is our regular speaker and our Jakarta EE expert and technical writer. So you will see a lot of, if you go to our resources pages on the website, you'll see a lot of guides and other resources that Lukman wrote. So yeah, Lukman will take you through this webinar today. No slides as far as I know, just from me. So it will be very dev focused and very technical. So hopefully exactly what you came here for. So yeah, just a reminder for those of you who have just joined, any questions if you have, don't wait until the end. You can put them in the chat, you can put them in the Q&A, whichever you prefer, and I will monitor them throughout the presentation, throughout the event, and make sure that we will get to them and answer them live. For if there will be any more complicated questions, we might need to take them away from the event, but we will do our best to answer them as we go along. So yeah, I think without further ado, I'll stop sharing my screen now and I'll leave you with Lukman. Thank you.
Yeah, thank you very much, Dominica. So I'll just go straight and share my screen. Yeah, hopefully everybody can see my screen.
Yeah, looks good on my side.
Nice. Okay, let me just enter presentation mode. Yeah. Okay, so Jakarta EE and MongoDB. The goal of this particular webinar is to showcase the flexibility of the Jakarta EE platform in being able to use it for modern paradigms, database or data storage paradigms. And one of them is NoSQL databases. We touched on, or we looked at using Google Firestore some time back, and today we are looking at MongoDB. So we are just going to go through a few preambles, and then we just dive into the code. Now, NoSQL, as we all know, is an alternative data storage engine for storing data for applications. And Jakarta EE as a platform perfectly works fine with NoSQL. Of course, there are different ways you can consume or you can use NoSQL in your applications. And one of them is, as we're going to look at, is through the use of Morphia, which is a Java library for managing your data in using MongoDB on the Jakarta EE platform. Now, as a pure Java library, it means you can just drop it into your Jakarta EE application and then start using it, as we're going to see. Now, MongoDB is a NoSQL document-oriented database. Document-oriented means that data is stored as documents in MongoDB. Now, you can think of MongoDB, a typical MongoDB database, as a giant collection of, if you so will, JSON documents. So your data will be converted to JSON, sort of, not technically JSON as we are used to. It's much more like BSON or binary JSON, sort of. But yeah, just think of it as JSON. So your data is stored in MongoDB database as a collection of documents or key value pairs. That's all it is. Now, the data model for MongoDB is really not so different from that of the traditional database that you might be used to, for instance, in MySQL or Postgres or any of the much more traditional SQL databases. It's practically the same. You can take your data and then do something with it and get it into the database. Now, that something for this webinar is what we are going to look at. Now, Morphia is a Java library that sits between your application code and the MongoDB database, and then transforms your Java classes to MongoDB documents, and then also reads those documents and transforms them into your Java classes. So now let's take a look at our simplest entity, this hello entity, for instance. This is a plain old Java class that is underwhelming, if I should say. It's a Java class with some fields and all that. Now, Morphia stands between this class and the MongoDB database. So it gives you the API construct to transform this class into a collection, a MongoDB collection. And within that collection, you can drop instances of this class. Now, a collection in MongoDB is not so different from a table in the traditional SQL database sense. And within that collection or within that table, you can store instances of your class. So in this case, an instance of this hello entity here can be stored in the hello entity collection or hello entity table. Now, this is one of the things you can do with Morphia. You can customize this mapping. So we can say, okay, we want to save our hello entity in a collection, or if you so will, a table with a different name. And Morphia gives you the construct to do that. So in this very simple hello entity, for instance, we are setting this to hello, as you can see here. So this hello here is going to be the name of the collection that this particular Java class is going to be mapped to in our MongoDB database. So Morphia sits between your application code and the database and does these conversions for you. Now, it doesn't just do the conversions, it also gives you the construct to actually save data, instances of your mapped entities into the MongoDB database instance, and then also to query the data, much more importantly, because saving data is really useless if you can't query that data. So it gives you the construct or the APIs to also query that data. We'll be looking at all of those down the line. But for starters, the simplest unit of a MongoDB entity is a Java class. Now, if you are used to JPA entities or the Jakarta Persistence API, an entity is simply a Java class that is mapped to a database table. And in the NoSQL world, it's the same thing. An entity is a Java class that we simply map to a collection in the MongoDB database. So for this example, we have a hello entity here that we want to map to a collection in the database. But in our case, we just want to say, we are saying that we want the name of the collection, again, or the table. If you are used to the SQL names, the name of this table, the table we want to map this entity to should be hello. So we set it here. Now, this annotation here is from the Morphia API. As you can see, it's from dev.morphia.annotations.entity. So here we annotate our entity or a Java class. Now, don't get confused or overwhelmed by the word entity. It's just a special nomenclature to refer to a class we are mapping to a collection. So in our case here, this hello entity here is annotated with the @entity annotation. And we are passing in a parameter here. This parameter means that this particular hello entity is going to be mapped to a collection in the MongoDB database with the name hello. So instances of this class are going to be mapped to documents in the hello collection in the MongoDB database. And as you can see, we have some fields here. Now, we are not touching on customizing fields or anything here. Each field here is going to be mapped to a column in the collection. Really not so different from the traditional SQL database where a table has columns. It's the same thing. So each field here is going to be mapped to a column in the database. Now, in the absence of any customization, the name of the field here is going to be the name of the column to which it is mapped in the collection, in the MongoDB database. So for this particular hello entity, we are going to have the field name, greeting time, greeting, blah, blah, blah. They are going to be mapped to the same names in the, or as columns in the collection. Now, the only exception we have here is for the ID. Now, every database table needs an ID column. Every database needs a technical identification to be able to differentiate each inserted row or instance. So each instance inserted into that table, or in this case, the collection, should have a unique identity. Now, the way of identifying each inserted row is by giving it a technical ID. And one of the ways of creating a technical ID is by annotating a field of type object ID with the @ID annotation. Now, this is also from the Morphia API, but this object ID type is directly from the MongoDB API. So as you can see, it's from org.bsum.types.object_id. So this particular type here is going to be the database technical ID type in the database, in the collection that we create in the MongoDB database. So think of it now, if you are used to, again, with a database like MySQL, you could use a type like long or really integer as the ID type. Here we are using the object ID type because MongoDB has its own construct for creating primary keys. So this here is going to act as the primary key of the hello entity collection in the MongoDB database. So this is our first look at mapping entity. Now, with just these few constructs here, this class is going to be mapped to a collection in the database, and instances of this class are going to be inserted as rows or documents in that collection. Now, let's just take this for a spin. As usual, let's do a hello world, traditional hello world. Let me undo this presentation mode here. Is it? Yes, good. Now let me come to my, here, we are going to make a hello world call. Ignore everything up here, we'll come to them. We are going to make a traditional hello world call here. Let me just hit this. And then as you can see, I have a result here. Now let's go into the database. This is my hello. Now, as you can see, this is my MongoDB database. Now you might be wondering, how am I running this? I am running everything as containers locally. For the Jakarta EE runtime, I am using the latest Payara Community Edition, Payara 6.2023.4 JDK 17 version in Docker. I'm running this. Everything is running as Docker containers. And for the MongoDB database, I am pulling in the Community Edition 6.0.4. And I've created some initialization here, the initial database and blah, blah, blah here. And that is what I am using in my IDE here. So back to the collection here, as you can see, we have our entity, our hello entity here, mapped to the hello collection here. Now, this hello collection name here is from this particular customization we did. Now, in the absence of this collection would have been called hello entity, but we just wanted to customize it. Why not? We are developers, we always need a hello world. So we have a hello collection. Now, within the hello collection, you can see the fields in here. So every single field in this class here has been mapped to a column in this particular collection. Now, with the exception of the ID and this type columns here. Now, this ID, this underscore ID, is from here. This is telling, with this annotation, we told Morphia that, yes, take this field and then make it the primary key. And making it the primary key, we end up with this column here. And so this is the primary key column, as you can see. Expand this is the primary key column. And then we have our other Java fields here. Now, this particular type here is also a Morphia construct to tell it the specific type that each particular collection belongs to. So with this, with just these two annotations here, we have our database, we have our collection in our MongoDB database, and we can simply insert instances into it. Now, the process of inserting instances is what we're going to look at next. How do we, or how is this working? How do we use the MongoDB construct? Much more importantly, how is the MongoDB construct used within the context of Jakarta EE? And that's what we're going to look at next. I have a simple controller. For your convenience, I created everything in a single place. Now, the root entry point for Morphia is the data store object. Now, this data store interface here is really not so different from the entity manager. If you are familiar with Jakarta Persistence API, it's really not so different from the entity manager. This interface here has methods for interacting with the underlying MongoDB database. Really not so different from how the entity manager abstracts you from the underlying database. It gives you methods that you can invoke to interact with the database. It's the same thing. So data store here is an interface. We can just take a quick look at it. here for carrying out various operations for the underlying database. Now, how do you initialize this? There are different ways of going about it. But since we are using Jakarta EE, we decided to, why not use the construct available to us? And that is exactly what we've done here. So you can see I am injecting an instance of the data store into this field or into my data controller class here. So what I'm doing is delegating the management of this particular instance to the Jakarta CDI. Now, where is this coming from? Of course, this artifact here is not part of my code. It's from a third-party library. So the Jakarta CDI should have a place where it can go to get an instance of this to inject into this file for me. We can just go to where it's produced. So I'm using a producer method here to produce instances of my data store. So over here, we have a method, generate data store, that is annotated at application scope and at producers. Now, if you are not familiar with CDI or context and dependency injection, it is think of it as the underlying glue that holds together the various parts of the Jakarta EE platform. So CDI gives you the construct to be able to manage objects and their relationships in your applications. So using the producers annotation here, we are telling the CDI runtime that anytime you encounter a request for this particular type, this method return type here, come and invoke this method and then use the returned instance as the value to inject into wherever there is a request for this particular data store type. And that is exactly what the runtime is doing. So it's going to come here when it encounters this at inject here, it's going to simply come to this method, invoke it automatically, and then populate this field with the returned instance. Now, what I'm doing is setting the scope of the returned instance to an application scope. An application scope simply makes this particular instance here a singleton. Now, this is a heavy object to instantiate. So we just want a single instance across the application. There's really no point in creating new instances anytime we need one because it's quite a heavy object. So all we are doing is saying that just create a single instance, scope it to the lifespan of the application, and then inject it anywhere it is. So now, with this out of the way, we'll construct the data store using the Morphia API. As you can see, we do a Morphia. These are all from the Morphia API, and the code will be available for you to peruse later on. We just call some methods on some convenience methods or classes in the Morphia API to create an instance of our data store here, passing in the client and the connection string and everything. And the connection strings we are using here are also passed as config properties. Now, these config properties, we are using the microprofile config API to pass these properties. The idea is that in application development, your application is going to go through different phases. You have development, you will have testing, you will have staging, and then finally you have production. In certain places, you might have certain intermediate steps as well. Now, we really don't want to have to change our application or redeploy or recompile our application for each stage. So using the config property, we are passing in these particular values so that dynamically, depending on where or which stage we are, we can pass different values. Now, the microprofile config property or the microprofile config API has the concept of ordinal for config sources. So in this example, for instance, if I navigate to the properties, this is where I am setting these fields here in the microprofile config properties file here. Now, in staging, for instance, you can have another config source that has a higher ordinal. So in staging, automatically the config runtime is going to go to the config source with the highest or with the higher ordinal and then pick the same values from. So dynamically, without changing anything in our code, we can set different connection strings, different deployment stage, and different database names depending on the environment. We do all of that using the microprofile config API. So we set everything here, and then down here, we say if it is development stage, then simply drop the database and recreate it again. Of course, if you're in production, you don't want to drop a database haphazardly in production. We want to do this only in development stage. So we check if it's development, and then we do this, and then we ensure indexes, then we return the data store. Dominica, is there any question for me so far?
Yes, we have one question actually. So the question is there the possibility to generate entity from MongoDB database we can use with IDEs like NetBeans or Eclipse?
Yes, there should be. I haven't tested that coming backward from the database to the entities, but there should be, with a little bit of effort, you should be able to do that. With a little bit of effort, you should be able to do that. But it's really not something I would advise. If you have a situation where you have an existing database you need to work with, then you might want to step back and then reconstruct the Java part of the database and then link the two of them. I wouldn't really walk back from that, but it should be possible to be able to walk from the MongoDB database to the Java side instead of going from the Java part to the MongoDB database as we are doing here, which is the norm anyway.
Okay, yeah, thank you. That was the only question for now.
Okay, great, good. So now with our data store injected, we are ready to use it. So let's come down here. Let's start with the greeting. This particular greeting here, this is where we instantiate it. We instantiate the class, do a few housekeeping, blah, blah, blah here. And then we call the save method on the data store. Now, this save method here takes an entity. If you look here, it takes a type, a Java type, which is an entity. Now, the type that you pass to the save method should be an entity in the sense that it should be annotated with the @entity annotation. And that is how Morphia knows that this is an entity that is being passed to it. Now, if you come here to where we instantiate the data store, you can see one of the things we do here is to say data store.getMapper.map package. So we map a specific package. Now, if you go to this particular hello entity here, you go to the class, you can see all the entities are here. So every entity in here is known to the data store object here already because we have mapped it. So we pass an entity here and say save it. And in calling this, we end up with this. So this is what we have in here. Now you can see the various types, the JSON object. This JSON object is directly from the MongoDB API. And then we have string. Now, if you come into the database, you can see how they are both represented. The JSON string, as you can see, is represented as a raw primitive type. But if you look at the random data, which is here, the JSON object type, you can see it's represented as JSON here. And that means you can actually query this JSON. But of course, this is for you to explore later on. You can actually query. So all the types that MongoDB has are available for you to use. Now let's go to our actual entities. We have an employee, and then we have a department entity. Now, a department entity is a department that has a number of employees. A department, as usual, has one or more employees. What we have here, in addition to the @entity, as you can see, the @entity here, we have not passed any parameter to it. So if we come to the database here, you can see it's department, straight, no change, nothing. Just takes the name of the class and then use it as the name of the collection. So for our department, we have an entity, and then we have indexes. You can index fields for better performance. We index the department code and then the department's name here. And then we have a list of employees here. Now we have another annotation here, which is the reference. The reference here tells MongoDB that the target of the collection type here is an entity. So we are creating a sort of entity relationship here. Now, again, if you are used to, or if you are familiar with the Jakarta Persistence API, this is similar to saying one-to-many, which creates a relationship between the department, which is the one side, and the many side, which is the employees. And it's the same thing we are doing here. We are saying at a reference here, we are using as reference here to tell the Morphia runtime that the target type of this collection are entities. So treat it that way. There's a relationship between them. So treat it that way. Now we pass in the value or the parameter lazy here to say lazily load this. We don't want you to load an instance or this collection anytime we load an instance of this. That will be very, very non-performant. So we are saying that only load the employees when it is actively requested during the load time. Really, this is no different from saying at one to many like this, and then we can say the fetch type lazy. This is really no different. This construct here is really the same as this. So we are saying lazily load these entities only when they are requested. So now we have mapped our department, and then let's just walk to our employees here. The employee class is really another Java class with a few fields here: first name, last name, employee ID, blah, 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 and all that here, as you can see, all these employee ID, blah, blah. And then the employee is also indexed here. We'll be talking about this particular index a little bit in a while. Just bear with me. We have indexed these fields. Now, as with even with the traditional SQL databases, indexing is very important to be able to search, especially if you know you're going to be querying by those fields, then you want to index them to make them as fast as possible. So we index our fields here. And if you are taking notes, you can see there's a slight difference between the ID type of the employee and the ID type of the department. The ID type of the employee is the object ID type. This object ID type, we already encountered it in here with the hello entity. But the ID type of the department is of type string. Now, Morphia has support for these two types, meaning underlyingly, MongoDB has support for these as well. So you can use the Java type string as the ID or the primary key type, or the object ID type here. I personally prefer the string because I find it to be much more easy to use. But of course, this will depend on your preference and requirements and all of that. But I prefer using the string type here. But you have these available to you, so you can use the object ID or you can use the string type. So we have these here, and really this is all you need at their simplest part. This is all you need to map your entities to the database. So if you come here, you can see the department is mapped, but there's nothing here because we've not put any data. Now, if this were a SQL database, you would have seen the columns. But because this is NoSQL, it's just a giant map. As you can see, it's just a giant map. There's nothing in it. You need to insert data before you see the columns. Unlike the SQL databases where the tables are created and the columns are created upfront, whether there's data or not. For the NoSQL, of course, this is one of the powerful parts of it where you can, it's dynamic. If you put data in, then you see it. If you don't put data in, then that ends it. That's what we have here. So We've seen this mapping the entities and then getting a hold of the controller, which is the data store. Now let's go and see these in action. Let's start first by creating a department. Of course, you can't have a company without a department, and employees in a company don't exist or can't exist in a vacuum. So we start with the department. Let's hit send. And then as you can see, we have a department created for us, returned to us here. If we go into the database, departments, you can see now we have our department. The ID is set for us. The type is department. This is done for you. You don't need to do anything. You only need to pass these two fields here. Now, if I also pass wrong data, I should have some basic validations in place. So if I pass wrong data, you can see there is a validation error thrown. Here, you can see there's a validation error thrown that the department code is required. Now, this department code is required because over here, we set it as not empty. And this is from the Jakarta Bean Validation API. Of course, you shouldn't be able to persist a department without some form of unique identifier in your system. In this case, the department code. A lot of companies will have behind the scenes, each department will have code. For instance, in our example here, we are using Finance 01 to denote the department name. So we can do something like that, but each department should have some form of unique identifier, and that is what we are simulating over here. So with our department name, let's go back to our department database here. Department name, code, and everything is done. Now we can create employees by passing the department code. Employees can't exist in a vacuum. Employees exist in a department. So to create an employee, you assign them to a department. And that is exactly what we are simulating with our REST endpoint here. And for your convenience, let me just show you the REST endpoint, employee resource. It's really using the Jakarta REST API to create the REST endpoint. So let's start with the department since we've already made a request to that. This is the department resource. We simply have a Java class annotated with produces and consumes, and then a path. So our class is hosted at this path, which is exactly what we have here, department, and then some methods, department resource here. And then we have a method here, a post method, which is what we did. We posted to the department resource. And then we just took the past instance, gave it to our controller, and then returned whatever the controller returned. Now, this @valid here is what gave us the error that we had, this particular error, when we made the wrong call. This @valid here is, think of it as a preemptive validation. So if we annotate this particular class, as we have annotated this class with the @valid annotation, then when you make a call, the bean validation runtime is going to take the instance and then trigger validation. And the validation is going to be recursive. Anything that has annotations, the bean validation annotations, is going to be validated. If there is a validation exception or there is a constraint violation, then an exception is thrown. And again, using the bean validation, the Jakarta REST API construct, we have exception mappers to actually catch the thrown exception and then return the beautiful validation error messages we are seeing here. So this error message, for instance, is from our constraint violation exception mapper here. Now, if we go into our data controller, we have a validate method here. This validate method takes an object, and then we use the bean validation API to validate. So here we say validator.validate, and then if there are any constraints here, it means something went wrong. We throw the constraint violation exception, and using our constraint exception mapper, we catch that exception and then craft a beautiful response message and return to the client. So the beautiful response message you are seeing is from here to the client. So the client can know that this is the error message. And you can see we include the resource endpoint, and then a helpful validation, a title. Then we have the class, the field name, and then the violating message here. And this is all from the Jakarta API. There's no third-party library. The only third-party library we are using here is the Morphia library dependency in our code. So back to our REST endpoint here, we have created a department which is in our database. Now we are going to create an employee. We hit send. Okay, since there is an exception, I did a change right before coming back in, but yes, we hit send, and then let's come here. We can debug this together. Come here, come to the, now again, this is everything is running in Docker here. If you come back down here, we can attach a debugger to it and find out exactly what is going on. As you can see, it says recursive reference has been found in class fish.employee.blah blah blah. So we can come here and check what is the recursive down here. You can come here and say, okay, exactly what is going on. It says there's a recursive reference here. There's some B exception. You can check. First, let's attach the debugger. Run. Okay, so now we have a debugger attached to our container. We can put our breakpoints here, save employee, and then find out exactly what is going on. So let's make our request again. First, let's wipe our server log, and then make our request again here. So good. So we have our employee here. Step over. Validation is okay. Now set employee ID should also work. Okay, now let's say assign department. Let's walk in and see what is going on. So here we are in assign department method. Of course, this code will be available for you to take a look at. So don't stress very much. It will be available for you. You can play around with it as your heart pleases. Step over this. Okay, so we have our department returned to us, which is fine. So up to this point, there is no problem. Step over again, step over this, step over this, step over. Step over, step over. Okay, so there seems to be a problem at our REST endpoint here. So again, as we are doing this live debugging, we can just say data controller, but save employee. Or let's just copy this. Dominica, do you have any questions so far?
No more questions at the moment.
Okay, so now let's check if runtime gets to this point, if this is returned to us. But before then, we need to just redeploy this. I can say maybe clean package, skip test. Of course, I could also set this to auto-compile and all that, but I'm old school and I prefer doing this. Copy this and paste this in here. Now, you might also be wondering what I am doing. The Payara server has a folder, auto-deploy folder that I've mounted to a local folder here. So anytime, now that auto-deploy folder, simply there's a scanner scanning the auto-deploy folder. So anytime there's a WAR file placed in there, it simply auto-deploys. And that is exactly what I'm using locally. So I have this folder where I drop in my WAR file, and then the runtime simply scans it and then deploys any WAR files that are dropped in there. So as you can see, the WAR file I dropped in there has been deployed. So let's go back again and try. Yes. Go. So go. Now let's run to this part. Okay. So execution doesn't get to this place. So we know that between this controller and returning to this place, there is a problem. But if you go into the departments, the employee database, you can see our employee has been persisted just fine. Here, you can see our employee is persisted in our database just fine here with blah, 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 12,000, blah, 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 and John Jakes, blah, 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 and all that. So this employee, or where is it? Employee here, mapped to our database here. Employee, and close this. Employee, we have our data in there. Now, for brevity of time, let's walk down to query. Of course, we can also query. Now the code will be available for you, so don't really worry very much. There was a problem, there was something I changed right before we started this session, and that is making JSON be a little bit unhappy, but the code will be available for you to take a look at. Now let's go back to our data controller here, and then check. Now Morphia allows you to query the underlying MongoDB database in two ways. You can query using the traditional way, fields in the class. You can filter greater than, less than, blah, blah, blah. Or you can do a direct text search. Now, I personally find the text search option very powerful because every field that is of type string in a given Java class, you can simply search for it. So for instance, in this employee class here, with this particular construct here, this indexing here. Now, of course, to search for text string or text fields, to do text searching, you need to index the fields, the text field. And that is exactly what we have done here with this index, this particular special index here. We have indexed all the text fields in here. This, so this, and this, and this, and this are all searchable. Now, if we come to our controller code here, if you come to our controller code here, you can see we do a data store. Again, everything revolves around the data store. This query and this query are all revolving around the data store. So the data store is essentially the entity manager of Morphia when you want to, or when you have to interact with the MongoDB database. So we down here for the text search, we do a data store.find. Then, of course, we have to pass in the type because this is type safe. Everything has to be type safe. We do a data store.find. We pass in the employee.class, and then we say filter. Then we pass in filters.text, and then we just pass in the text search. Here, I find this really powerful because then it makes searching easy. Now compare this to this. There's a lot of code to write to search for fields. If, of course, a Java class doesn't have only string types, but the large part of your fields are going to be string types. They're going to have first name, last name, or whatever domain you find yourself in. You're going to have the significant part of the fields being string. And if you have a simple way to search for that, then I find it quite powerful. So with this simple construct here, you're going to search for, or the runtime, which is Morphia, is going to search for the underlying database, all field types. It's going to search and return to us. So if we do a simple query like this, it's going to return to us all the fields. No, not hello, this one. Search, yes. It's going to return to us. So you can see it returned to us, even with the age and everything. Now, this age, if you come to the database, the employee database, there is no age field here. But this age, when the employee is returned, instance is returned, you can see there is an age field here. Now, if you go into the employee entity here, there is an age field here, but it is marked thus. Now with this, we are telling Morphia that this field here should not be mapped to the collection, the underlying collection for this employee. So if you come to the employee instance, there is no age here. There is no age in here, but it's in here. Because of this annotation, those will not be mapped to the underlying collection. And then what we are doing is that when an instance of an employee is loaded from the database, we want to hook into that. That is an event. So for this particular case, it is a post-load event, i.e., after an entity has been loaded, so post-loaded, of course. So in here, we are simply calculating the date. And so this particular 77 is from this particular piece of code. So we are taking the date of birth. In this case, it is 1945, and then it is subtracting today's date from it, and then giving us in years, 77. So this particular field here, even though it's not mapped to the database, we are still populating it here using a callback. And this post load here, again, if you are used to, or if you are conversant with the Jakarta Persistence API, there's a similar construct where if an entity is loaded from the database, you can hook into that event and then do some kind of initializations. And that is exactly what we are doing here using the Morphia API construct here. So we are doing that, and you can see that our text search, our text search is returning the employee to us. This text search here is defined in the employee resource. Close this. Employee resource here, text search. So we just pass in a search term, and then over here we do a data store.find employee and then filters.text. I personally like this particular function in MongoDB and Morphia as well, because it's quite powerful and simple and almost free text search out of the box for you to use in your application and all that. So to recap, the Jakarta EE platform gives you the various tooling and constructs that you can put together to use various libraries. One of which is, as we have seen, using the Morphia library to interact with the MongoDB database. Now, as you can see, there is nothing extraordinary we have done here. It's just plain old Java and using the Jakarta EE APIs, and then we are persisting data. And in the age of containers, you can see how there is, everything is almost simple because we are pulling in the database and the runtime, the Payara runtime as containers and running everything. So the Jakarta EE platform is that flexible that you can use it for all these. You are really not limited to the much more traditional SQL alternatives or SQL databases. You can use the NoSQL databases as well. But of course, you are not limited to just MongoDB. You can use the same construct that you have seen here with all the other NoSQL, almost endless NoSQL databases out there, from CouchDB to all the cloud-hosted options and everything. You can do the same thing. You can do the same thing using the same construct and everything you have seen so far. To recap, finally, the Morphia library gives you various constructs to consume or use the MongoDB database. Now, I use Morphia and I recommend Morphia because I find it to be much, much closer to the Jakarta Persistence API. If you have used Jakarta Persistence API before, Morphia is really modeled along the lines of Jakarta Persistence API. Much close, much familiar than using the MongoDB Java library directly. It's the MongoDB Java library, I find it a little bit verbose and in some ways a little bit complicated. So I recommend using Morphia as much as you can. But of course, if your domain allows it, then you should take a look at Morphia, because then if you are used to Jakarta Persistence API, you will immediately feel at home with Morphia. And this is how you put libraries together and then use the various underlying construct that Jakarta EE gives you to simply use anything out there, really. You are not limited to anything on the Jakarta EE platform. As you can see, our runtime of choice, which is Payara, is pulled in through Docker containers. So with this sample code, which I will get uploaded to the examples project in the Payara organization on GitHub, you can just pull this and then just play around with this. If you are new to Payara, you're just going to feel right at home because everything is containerized and you can play around with it. Dominica, is there any question for me?
Yes, so we've got one more question. Does Morphia work with standard Jakarta EE JPA?
Morphia is a library for using MongoDB. So the standard Jakarta EE JPA, Jakarta EE, Jakarta Persistence API, is mostly for interacting with the traditional SQL databases. And Morphia is specifically for MongoDB. But of course, you can have an application where you can use the two. So in this case, we could actually annotate this employee again as at entity, like this at entity, and this would be from the Jakarta Persistence API. So this entity will be mapped to a relational database and a collection in MongoDB. But of course, in that case, then you are talking about very complex applications. But yes, you can use the two of them side by side in the same application. But Morphia is much more restricted in the sense that it is for specifically mapping and using MongoDB in Java applications.
Okay, great. Yeah, and that was, I think, the only question for you, Lukman. Just to clarify, because someone was asking as well about the recording. So yes, this webinar is being recorded. I should have mentioned it at the beginning. And it will be, if you want to go back to anything that Lukman said, because yes, there's quite a lot and there's a lot of code. So if you want to go back to it, you can access this video of this webinar through the same link you actually used to enter the webinar today. It should be available within half an hour after we finish. We will also, in a week or so, upload it to YouTube, and you will be able to see it on our blog and on our YouTube channel. So yes, the video will be available.
Yes, so I hand over to you, Dominica, and if you have any question at any point, feel free to reach out to us on our social channels, and then we should respond to you. Yeah.
Exactly. Thank you. Thanks, Lukman. That was very, very useful. And yeah, and I shared, because Lukman, you mentioned the examples that we will share the code on GitHub. So I send you all a link in the chat to GitHub Payara examples, or just Google literally GitHub Payara examples and you'll find it there. You will find some examples from previous webinars as well. If you attended those and you were not aware, they're there. And it's the same case for the videos. All of our webinars are always recorded. They are available on YouTube channel a couple of days or up to 2 weeks after we do the webinar. If you want to see them earlier than that, you can go through the original Zoom registration link, because that's where they are available for the first few days. As will be the case with this one as well. And for those of you who are not necessarily familiar with Payara platform itself, I just wanted to quickly show you that obviously we have Payara platform community, which a lot of you are already using, and maybe some of you are not aware that we also have the Payara platform enterprise, which is fully production ready, Jakarta EE compatible runtime that you can use for your production environments where you need security, reliability. So you can actually try it for free. So we have a very easily available trial. You just go through our website, you click the try it button, and you just fill in the form, and you will get a trial link emailed to you directly. And obviously it does not include the support, but it does include the Payara Platform Enterprise software. So you can have a look, see what it is, see how it works, and make your decision on whether it's the next step for your journey to move from Payara Platform Community into production with Payara Enterprise. So I definitely recommend you to do that. It's very, very easy. So yeah, I think that's all for now. I'm just checking quickly if there are any more questions. I don't think there are, no. If you do have any questions beyond this webinar, then as Lukman mentioned, reach out to us through our social media. You can email us at info@payara.fish. You can go through the contact form on the website. Whichever way, you can comment on blog posts. You can comment on our YouTube videos. We monitor all of those. So and we try to respond to you as soon as possible. So yeah, I think that's all for today. We are 1 past the hour, so just on time. Thank you very much, everyone. Again, I hope to see you at the next event in the next couple of weeks. And thank you very much, Lukman, for another great presentation. And yeah, have a great day, and we will see you soon. Thank you. Bye-bye.